Good afternoon, this is Cristian Jimenez with Hector Martinez. We are Group 3 and we will present in this video the project number 1 of the subject Computer Applications in Power System, code EH2745. So let's start. Initially, in our code, we will be working with the Python software instead of Java. So we create classes for every object. Every object has its own document. For example, power transformer end, which is the required information that is it must be obtained, and is the requirement here in this table. So what we are doing, as we have the object, we create again a class, and for every class we will set some attributes which are here listed. As we are dealing with Python, and prior to start, we need to delete the URL, as in Python the CMSpace acronym was replaced initially by the URL, and this one can be quite annoying to start working. In order to do that, we query the XML tree via path, which will remove the argument, and the XPath it will be used to query the XML structure. Getting all the XML structure, we can easily obtain all the parsing information from the network. Simultaneously, we will do the same for the EQ reduce XML file, as well as the SSH reduce XML file. Now we can start with our first class, which is the base voltage, created in for our first object, created in a class which contain the ID, the name, the base voltage, and at the end, after getting all the attributes of this class, those attributes will be sent into an array list, which will go at the same time to the memory. We proceed in the same way for base voltage, for substation, for the voltage level, as well as for the generating unit. But when we reach the synchronous machines, that in our case we have only one, here we start with the SSH. With the SSH files contain all the operation of the electrical network. From here we will obtain the P, which means the active power, as well as Q, the reactive power of the rotating machines. At the same time, we open the XML file, which is the EQ reduce file, and we obtain the ID, the name, the rated power, the machine, the regulating point, and the equipment container. But as you can see here in the list at the end, we have a base voltage. And if we go to the EQ reduce file, there is no direct information regarding the base voltage. So for that case, we will have to use a cross-reference, which can be easily done by analyzing this picture. First, as it is required to obtain the base voltage, we can read the base voltage ID and make this reference and try to join them in order to find the base voltage which goes to the voltage level. Then for the regulating control, we obtain the target value. We proceed in the same way as we have done it in the synchronous machines, as we have to find different values in two different files. Power transformer, it's quite easy because we only have to read one file, while for the energy consumer is the same required to obtain P and Q, obtained from the SSH file, ID, name, and equipment energy consumer, obtained from the XML EQ reduce file. But, as well as in the previous one, we need to obtain the base voltage, which by using our cross, we read the base. If we want to read the base voltage, we go to the RDF ID of the base voltage, and then we can easily obtain the voltage level. That methodology will be performed for the following classes: power transformer and the breaker, as well as the ratio tap changer. Additionally, we also like to include the resistance as well as the reactance of every line, which will be useful later to obtain the Y matrix.
After that, we create a function called topology generator, which will change or make the topology as is required in the project. So from the information that we already obtained, we create this function and we start making our little nodes, which are going to be composed by a conductive node, terminals, and conducting equipment. So this is what we do first. We find all the connective nodes. We go and find them in the file. Then we find the terminals and map them to the connective node. We add all the information that is required or that we found interesting for solving or to implement our solution. After that, we also find the conductive equipment and add it to the terminal. First, we're going to look for the bus bars in case they are. Then we'll do a similar process for the power transformers, for the breakers, for the generation units, for the regulation units, and then we find the loads or the energy consumers. Finally, synchronous machine in case there is some power transformer, and we do this with all the equipment. In this way, what we're going to do is we're going to make these blocks of the topology that will relate every other element with each other. Here we can see where we initialize everything. So we're going to make list of the classes that Karim previously explained. So we have base voltages, substations, voltages, etc., etc. We can see here at the end how we're going to start making or building our power grid, what is called. So we have a node number, we add a terminal list, and in case it has a conducting equipment, we're going to add it. The only thing that will change if it's an AC line, if it's a power transformer end, if it's a synchronous machine, etc., etc. The process is kind of repetitive, but we do the same with all the topology. After finishing this, we already have everything in the memory. And then we execute our next function, because that is called calculate Y-bus matrix. Is another file. And we call these zones. So we are trying to divide in zones. We use already all the information that we obtain. In this case, we can use the power grid. We will use the voltage level list, the bus bar, etc., etc. Then for start making our zones, first we need to look for the 4-bus section. This is what we do here. And then we're going to try to find the base voltage that is attached or that correspond to that bus bar. We start looking at this. And then we can start looking for power transformer end. Since we are only going to consider lines as transformers, we're only going to find like the power transformer end. And then we're going to try to find the transformers and finally the AC lines. As is in the program, everything is related. So basically, first we find the bus bar. They're going to find the voltage level, then the base voltage of that, and after that, the power transformer end list, and finally the transformer. The advantage that we have with this is that we are using our little array list. So basically, we have all this information for the terminals, for a power transformer N, etc. So we are translating all the required or the interesting information in every piece of our code. At the end of this part, we're going to add what we have designed zones. These zones are going to be busbar sections with voltage level, with base voltage list, power transformer ends, and power transformer links, and actual line or the AC lines, which we're going to consider for calculating the Y matrix. Then we have the calculation, how to calculate the Y bus. So we have all these zones and we define all variables, the elements, resistance, the conductance, etc., etc. And then what we start doing is we just start iterating. First, we try to get the diagonal values of it, and then we try to find the other ones.
It is important here to remember that in the first part, we will try to obtain the elements of the main diagonal of the Y matrix. Just to remember, here is important because we will analyze if the zone has either an AC line or a transformer. In the case of AC line, we will use the pi model, which includes the resistance, the reactance, the susceptance, as well as the conductance of every line. Then, if it finds the value, we will obtain first the admittance of the impedance by obtaining the inverse of the resistance plus the reactance. The same for the shown reactance of the line. We use the conductance as well as the susceptance. In the case that zone has a transformer as well as a reactance of the transformer, it will be also add. And at the end, for main elements, is the sum of all the admittances connected to that bus. Here the 0.5 is because the total shown admittance of the line in the model is split into two parts. For the outside elements, the bus, here is important because we will compare the IDs of either transformer and AC line, which means that if two buses have the same ID of either a transformer or a power line, it means that those two buses are connected. So they will have, in that case, a value which can be a transformer or an AC line. But with the difference that at the end, it will be the sum of all the admittances connected between those two buses, but with a negative sign.
Then after we have all the calculation, we just return to the main program, and then it ends here. So basically we have this get information function that is the parsing part. We also have the calculate Y-bus matrix, and as we previously explained, we have the topology generator. There are mainly three functions. We classified in classes, and we use array list since we found it was most easier to manipulate or to use the information that were obtained from the files. Thank you very much.